Welcome to Creative World. In this video, we will solve Chapter 3 Learning Assessment E3.22. While solving this problem, we will be using Kirchoff's voltage law. According to this law, sum of all supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Learning assessment E3.22. Find the value of voltage V0 in given below figure using mesh analysis technique. This is the circuit diagram of given problem. Inside this network, we have to find the value of voltage across this 6 kilo ohm resistance with this polarity, and these voltage are labeled as V0. We have to adopt the mesh analysis technique for the solution of this problem. So without wasting time, let's proceed towards the solution. First of all, in order to do mesh analysis of any network, we have to find the maximum number of meshes that can be formed inside that network. Using this equation b minus n plus 1, we can find the maximum number of meshes that can be formed inside this network. In this equation, b is the number of branches and n is the number of nodes in that particular network. In this case, number of branches are 10 and n is 8. So 10 minus 8 plus 1 will result 3. So maximum 3 number of meshes can be formed inside this network. In next step, we will form 3 meshes in this network and will assume currents along with their directions inside these meshes. Polarity notations across resistive elements are marked according to the directions of currents. Now we will start writing KVL equations from this mesh 1. KVL equation for this particular mesh will be, we will start from here, current entering terminal is positive, so voltage across this 4 kilo ohm resistance will be taken with positive sign, and voltage across this resistance is the product of current through it and the value of resistance. Two currents are passing through this resistance because it is common between two meshes, and both of these currents are opposite to each other. Current I1 is flowing in downward direction while current I2 is flowing in upward direction. Difference of these two currents will be equal to the resultant current that will be passing through this 4 kilo ohm resistance. In order to find the resultant current through this resistance, we will subtract current I2 from I1. Here a question may arise why we did not subtract current I1 from I2. The reason is because we are in this first mesh and we are taking the polarity of voltage across this resistance according to the direction of current I1, which is showing that the magnitude of I1 will be higher than I2. That's why we have subtracted I2 from I1. So the voltage equation for this 4 kilo ohm resistance will be equal to the difference of these two currents, I1 minus I2 multiplied by 4 kilo ohm. Same case will be applied for this 3 kilo ohm resistance, but at this time the difference of two currents will be taken as I1 minus I3 because this resistance is common between mesh 1 and mesh 3. So voltage across this 3 kilo ohm resistance will be I1 minus I3 multiplied by 3 kilo ohm. Next, current entering terminal is positive, so voltage across this dependent voltage source, that is 0.5 times Vx, will be taken with positive sign. Next, current entering terminal is negative, so 10 volt will be taken with a negative sign. Next, current entering terminal is positive, so voltage across this 2 kilo ohm resistance, that is the product of current I1 and 2 kilo ohm, will be taken with positive sign. And same case will be for this 3 kilo ohm resistance. Product of current I1 and 3 kilo ohm will be taken with positive sign. Now open these brackets and place this minus 10 volt on the other hand side of equal to separate it from variables. Here the product of 4 kilo ohm and I1 will result 4k I1, similarly 4k I2. 3 kilo ohm will multiply with I1, it will become 3k I1 minus 3k I3 plus 0.5 Vx plus 2k I1 plus 3k I1. Now add values having same variables together. Sum of 4k I1, 3k I1, 2k I1 and 3k I1 will result 12k I1. Similarly, minus 4k I2 minus 3k I3 plus 0.5 times Vx will be equal to 10 volt. Now we have to replace this Vx with its value. Vx is appearing across this 6 kilo ohm resistance with this polarity, and this polarity is taken according to the direction of current I2. We can say that in this case I2 will be larger than I3. So voltage Vx equation will be equal to I2 minus I3 multiplied by 6 kilo ohm. Here the difference of these two currents are taken because this 6 kilo ohm is common between these two meshes, and current passing through this resistance is equal to I2 minus I3 because two currents are passing through it and both are in opposite direction to each other. Now open these brackets. Vx will be equal to 6k I2 minus 6k I3. We can replace this Vx with its value. Vx is replaced with 6k I2 minus 6k I3. Now open these brackets and solve this equation. 0.5 times 6k I2 will result 3k I2, and same case will be here minus 3k I3. Now add values having same variables together. The equation will become 12k I1 minus 1k I2 minus 6k I3 equal to 10 volt. We cannot further solve this equation, so we will leave it for now and label it as equation A. Now we will apply Kirchoff's voltage law inside this second mesh. KVL equation for this mesh will be, we will start from here. Current entering terminal is negative, so 12 volt will be taken with negative sign. Next, current entering terminal is positive, but voltage across the 6 kilo ohm resistance will be equal to the difference of these two currents multiply by the value of resistance. And because we are in second mesh, so I3 will be subtracted from I2. I2 minus I3 multiplied by 6 kilo ohm. Same case will be here. I1 will be subtracted from I2. So the difference of these two currents, I2 minus I1 multiply by the value of resistance, will be equal to the voltage across this resistance. Next, current entering terminal is positive, so voltage across this resistance will be equal to I2 multiplied by 4 kilo ohm will be taken with positive sign. Now open these brackets and solve this equation. Place this minus 12 volt on the other hand side of equal. This 6k will multiply with variables inside the brackets. It will become 6k I2 minus 6k I3 plus 4k I2 minus 4k I1 plus 4k I2 equal to 12 volt. Now add values having same variables together. The equation will become minus 4k I1 plus 14k I2 minus 6k I3 equal to 12 volt. We cannot further solve this equation for now, so we will leave it for now and label it as equation B and apply Kirchoff's voltage law in third mesh. Start from here. Current entering terminal is positive, so voltage across this 6 kilo ohm resistance, that will be equal to the product of current I3 and 6 kilo ohm will be taken with positive sign. Next, current entering terminal is negative, so voltage across this dependent voltage source will be taken with a negative sign, minus 0.5 times Vx. Next, current entering terminal is positive, so voltage across this resistance will be taken with positive sign, and this voltage are equal to the difference of these two currents multiplied by the value of resistance. Because we are in third mesh, so current I1 will be subtracted from I3. Voltage across this resistance will be equal to I3 minus I1 multiplied by 3 kilo ohm. Next, current entering terminal is positive, so voltage across this resistance will be equal to I3 minus I2 multiplied by 6 kilo ohm, it will be taken with positive sign. We know the value of Vx that we retrieved in previous step. Vx is equal to 6k I2 minus 6k I3. We will replace Vx with its equation and open these brackets. The equation will become 6k I3 minus 0.5 times 6k I2 minus 6k I3 plus 3k I3 minus 3k I1 plus 6k I3 minus 6k I2. Now again open these brackets. The equation will become, again open these brackets and multiply 0.5 with variables inside the brackets. The equation will become 6k I3 minus 3k I2 plus 3k I3 plus 3k I3 minus 3k I1 plus 6k I3 minus 6k I2. Now add values having same variables together. The equation will become minus 3k I1 minus 9k I2 plus 18k I3 equal to 0. This is the third mesh current equation of this network. Up to this point, we have retrieved three mesh current equations of this network, which are labeled as equation A, B and equation C. Now we will try to solve these equations to find the value of current I3. We are interested to calculate the value of current I3 because if we know the value of current I3, we are able to calculate voltage across this 6 kilo ohm resistance by multiplying current I3 and 6 kilo ohm. And we are interested to calculate voltage across this 6 kilo ohm resistance because these voltage are labeled as V0 and it is asked in this scenario to find the value of V0. So first of all, we will try to find out the value of current I3. Later on, we will apply Ohm's law to find the value of V0. In order to find the value of current I3, we will take equation A as it is and multiply equation B with 3. The equation will become minus 12k I1 plus 42k I2 minus 18k I3 equal to 36 volt. Now we will add these two equations together. This plus 12k I1 and minus 12k I1 will cancel out with each other. Only 41k I2 minus 24k I3 equal to 46 volt will left. Now again we will take equation A as it is and will multiply equation C with 4. The equation will become minus 12k I1 minus 36k I2 plus 72k I3 equal to 0. Add these two equations together. Plus 12k I1 and minus 12k I1 will cancel out with each other. Sum of 36k I2 and 1k I2 will become 37k I2. 72k I3 minus 6k I3 will become 66k I3. And on the other hand side of equal, only 10 volt will left. Now in order to find the value of I3 and omit variable I2 from these two equations, we will multiply this equation with 37 and this equation with 41. Product of this equation with 37 will result 1517k I2 minus 888k I3 equal to 1702 volt, and product of 41 with this equation will result 1517k I2 plus 2706k I3 equal to 410 volt. Now add these two resulting equations together. These two will cancel out with each other and sum of 2706k I3 minus 888k I3 will become 18k I3 equal to 2112 volt. In order to find the value of current I3, divide on both sides with 18k. I3 will become 1.16 milliampere. Now we have the value of I3, so we can easily calculate the value of voltage V0, that is equal to 1.16 milliampere multiplied by 6 kilo ohm. Taking the product of these two values, we will get the value of voltage across this 6 kilo ohm resistance, that is labeled as V0. So the value of V0 inside this network will be 6.96 volt. So this was learning assessment E3.22. Thank you. See you again in next video.